So we did problem number 25 on page 390 from 9.4,
So
part 1.
we were first given that HE, which is here, is 17 units, and HG is 10 units. We were also given that the whole of GE was 21 units, and that HFG formed a right angle.
And what we need to find for A is the length of HF, and we need to find out if triangle EHF is similar to triangle HGF.
So the first thing we did was that we named segment HFY and GFX, so it would be easier when we were making our systems. So using the thing h squared plus v squared equals c squared, we first used that this x squared adding this y squared would equal 10 squared. And then additionally, with using this as x and this is the whole as 21, we knew that 21 minus x squared add y squared would equal 17 squared. So we first had to distribute out 21 minus x squared, and we knew we'd get a trinomial because we had 4 numbers we had to multiply out. And we ended up getting 441 minus 42x. And so we applied that to the rest of the formula that we'd already gotten, and we had negative 42x, add x squared, add y squared equals negative 152. And we set that up as a system with the other one, which we found back here, x squared add y squared equals 100. We subtracted to get rid of the x squared and the y squared to end up with negative 42x equaling negative 252. We divided by negative 42 to get that x equaled 6, which was this number, but we're still looking for y. And we could set that up using the same thing we used here to get that 6 squared, which we found as x, is 36, and 10 squared is 100. And so we would subtract 36 from 100 to get 64, and the square root of that was 8, which would be y.
Okay, to figure out that the triangles are similar, we found out, we knew that x was 6 and y was 8. And so what we did was we found out that 21 minus x was 15, and we compared the sides like we learned, and we did 10 over 6 is 17 is to 15. And if they were similar, they would equal the same number, but since they didn't, triangle EHF isn't similar to triangle HGF.